Welcome to Mind Stretch. Today, we're diving into one of the most fascinating concepts in physics, the twin paradox. It's a thought experiment that challenges our understanding of time, space, and reality itself. Get ready to have your mind stretched as we break down the theory and work through a clear example. To understand the twin paradox, we first need to grasp the basics of Einstein's theory of special relativity. This theory tells us two important things. First, the speed of light is constant for all observers, no matter their motion. And second, time is relative. It can move faster or slower depending on how fast you're going. This is known as time dilation. In simple terms, time slows down for objects moving close to the speed of light. For example, if you're traveling in a fast spaceship, time would pass more slowly for you compared to someone standing still on Earth. Let's dive into the twin paradox. Imagine two twins, Alice and Bob. Alice decides to go on a space journey to a distant star, traveling near the speed of light, while Bob stays on Earth. When Alice returns, who will be older? According to special relativity, time will slow down for Alice because she's traveling at an incredibly high speed. This means less time passes for her compared to Bob on Earth. But here's where it gets interesting. From Alice's perspective, isn't Bob moving away and then coming back? Shouldn't Bob also experience time dilation? This is the heart of the paradox. To resolve this paradox, we need to look deeper into special relativity. The key lies in understanding acceleration and reference frames. When Alice turns around to come back to Earth, she changes her reference frame. This acceleration breaks the symmetry between the twins' experiences. While both twins see the other as moving during the trip, only Alice experiences the acceleration needed to change direction. This acceleration causes her clock to sync differently compared to Bob's, making Alice age slower than Bob when she returns. Let's work through an example to make this clear. Suppose Alice travels to a star 10 light-years away at 99.5% of the speed of light. For simplicity, we'll assume she accelerates instantly and doesn't need time to turn around. From Bob's perspective, the journey would take approximately 20 years. 10 years to the star and 10 years back. But for Alice, due to time dilation, the trip only takes about 3 years each way. So, when she returns, she'll have aged only about 6 years, while Bob has aged 20 years. So, what does this tell us? The twin paradox is a perfect example of how counterintuitive our universe can be. It shows us that time is not an absolute concept, but something fluid that can change depending on how you move through space. This isn't just a quirky thought experiment. It has real-world applications, like in GPS satellites orbiting Earth. These satellites move fast enough that time dilation must be accounted for, or our navigation systems would fail. Thanks for joining us today on Mind Stretch. We hope you enjoyed unraveling the mystery of the twin paradox. If you found this video thought-provoking, please give us a like, share it with your friends, and don't forget to subscribe for more brain-bending explorations. See you next time.